Welcome to a deep dive into a world where the rules of computing are being completely rewritten.
Yeah.
Today we're investigating the quantum computing race.
It's a really exciting time to be looking at this because it's not just about building faster computers. It's about tapping into the fundamental laws of physics to solve problems that have until now seemed impossible.
We're talking about a world where computers could design life-saving drugs
Yeah.
or model the universe
Yeah.
with a level of precision we can barely even imagine.
Yeah, that's right. And leading the charge in this quantum revolution are three tech giants you know well, Microsoft, Amazon, and Google. Each company has a different weapon in their quantum arsenal. And today we're going to analyze their strategies and see if we can predict who might win this race.
This isn't just a tech industry showdown, though, right?
Yeah.
The outcome of this race could have huge implications for all of us.
Absolutely. From more powerful cloud services to breakthroughs in medicine and material science, quantum computing has the potential to touch every aspect of our lives.
Okay, so let's break this down. For those who haven't spent their weekends reading up on quantum physics, can you give us a quick rundown of what makes quantum computing so different?
Yeah, you got it. You know how computers today use bits, which can be either a 0 or a 1?
Right.
Quantum computers use qubits, which can be 0, 1, or both at the same time, thanks to a mind-bending concept called superposition. It's like being able to explore every possible path on a maze simultaneously.
That's incredible. It's like having a computer that can multitask on an entirely different level. But it's not just about superposition, is it? There's something about these qubits being linked together in a spooky way.
You're talking about entanglement, and it's one of the things that makes quantum computing so powerful. When qubits are entangled, they become interconnected. Measuring the state of one instantly tells you the state of the other, no matter how far apart they are.
That's where it starts to sound like science fiction. But this isn't just theoretical, is it? These companies are actually building quantum computers.
They are, and it's a massive undertaking. One of the biggest hurdles has been creating qubits that are stable and reliable. You see, qubits are notoriously fragile. The slightest interference from the environment can cause errors, a phenomenon called decoherence.
So it's kind of like trying to build a house of cards on a windy day. One wrong move and the whole thing collapses.
That's a great analogy, and that's exactly the problem Microsoft is trying to solve with their Majorana 1 chip. They've created a new type of qubit called a topological qubit, which is based on these incredibly elusive particles called Majorana fermions.
I'm trying to picture these Majorana fermions. Are they like tiny subatomic ninjas?
Well, they're definitely difficult to pin down. What makes them special is that they're thought to be their own antiparticle, which gives them a unique kind of stability. Microsoft believes this stability will make their topological qubits far less prone to decoherence.
So Microsoft is going for stability, building a quantum computer in that perfectly still room, so to speak. But what about Amazon? What's their approach?
Amazon is tackling the problem of errors head-on with their Ocelot chip. You see, even with stable qubits, errors can still creep in, but Amazon is using a technique called error correction, and their Ocelot chip, which uses something called cat qubits, has shown the ability to reduce errors by a whopping 90%.
Cat qubits. Does this mean Amazon is building a quantum computer filled with Schrödinger's cats?
Not quite, but the name is a nod to that famous thought experiment, which highlights the bizarre nature of quantum states. Amazon's cat qubits are designed to be much more robust against errors, making their quantum computers more reliable. You know how frustrating it is when your computer crashes?
Oh, yeah?
Well, cat qubits are designed to avoid that on a quantum level.
So Microsoft is going for stability, and Amazon is focused on reliability. What about Google? Where do they fit in?
Google, as you might expect, is being a bit more secretive about their approach. Their Willow chip is shrouded in mystery. But they've made it very clear that they are a major player in this quantum race. Remember a few years back when they claimed to achieve quantum supremacy?
Oh, yeah, that caused quite a stir. It's like they fired a shot across the bow of the entire computing world, proving that quantum computers could outperform classical computers on certain tasks. It was like comparing a bicycle to a supersonic jet.
Exactly. And that's why, even though we don't know the specifics of their Willow chip, we can be sure that Google is pushing the boundaries of quantum technology. They want to build the fastest, most powerful quantum computer out there.
It seems like we have a real race in our hands here.
Yeah.
But why are these tech giants pouring so much time and money into this? What's the motivation behind all this quantum fever?
Well, let's look back at recent history for a moment. Remember the AI chip shortage a couple of years ago?
Oh, yeah.
Amazon, Google, and Microsoft were all heavily reliant on NVIDIA for their AI workloads. They don't want to find themselves in that position again.
So they're trying to avoid putting all their quantum eggs in one basket. They want to control their own destiny in this new era of computing.
Exactly. And let's not forget the financial incentive. NVIDIA generated over $130 billion in revenue last year, with half of that coming from cloud providers like AWS, Google Cloud, and Azure. That's a huge market that these tech giants are all vying for.
Okay, so there's a lot at stake here, both in terms of technological dominance and financial rewards. But what does this all mean for us, the everyday folks who aren't building quantum computers?
That's where it gets really interesting. This quantum race isn't just about who builds the fastest computer, it's about unlocking possibilities that could change our world in profound ways.
So we're not just talking about faster downloads and smoother streaming.
Not at all. This is about tackling problems that have been beyond our reach, from curing diseases to understanding the universe in ways we never thought possible.
This is all incredibly fascinating, but it's a lot to take in. I think we need to take a break here and let all this sink in. We'll be back soon with part 2 of our Quantum Deep Dive, where we'll explore the potential impact of this technology on our lives, both the good and the potentially not so good. Welcome back to our quantum adventure. I'm still trying to wrap my head around the idea of computers that can, tap into the fabric of reality.
It is mind-boggling, isn't it? And the progress being made is happening at an incredible pace. Just think about those advancements we discussed in error correction. Those cat qubits and topological qubits are really starting to make a difference.
It's like we're watching a whole new field of engineering emerge right before our eyes. But let's talk about what this means for the average person. How will quantum computing actually impact our lives?
Well, one of the most exciting areas is medicine. Imagine being able to simulate complex biological processes at the molecular level. Quantum computers could help us design personalized drugs, tailor treatments to an individual's genetic makeup, or even unravel the mysteries of aging.
So we're talking about potentially curing diseases that are currently incurable. That's pretty amazing.
It's certainly within the realm of possibility. And it's not just about treating existing diseases, it's about preventing them in the first place. Quantum computers could revolutionize drug discovery, allowing us to develop new therapies much faster and more efficiently.
It sounds like we're on the verge of a medical revolution. But what about other areas? We talked about cloud computing earlier. How will that be affected?
Cloud computing as we know it will be completely transformed. Quantum computers will power a new generation of cloud services that are faster, more powerful, and more secure than anything we have today.
So our favorite streaming services will be even faster, and our online banking even more secure.
Exactly. And it's not just about improving existing services, it's about enabling entirely new ones. Imagine a world where you can access personalized AI assistants that can help you with everything, from managing your finances to planning your next vacation, all powered by the immense computational power of quantum computers.
This is starting to sound like that future we always saw in movies, where technology anticipates our needs and makes our lives easier. But it's not all about convenience, is it? What about solving some of the big problems facing humanity?
That's where it gets really exciting. Quantum computers have the potential to help us address some of the most pressing challenges we face, like climate change.
Okay. How would a quantum computer help with climate change?
Think about the complexity of climate models. They involve massive amounts of data and incredibly intricate calculations. Quantum computers could analyze these models with a level of detail that's simply not possible with classical computers.
So we could make more accurate predictions about the effects of climate change and develop more effective strategies to mitigate it.
Exactly. And not just climate change. Quantum computers could revolutionize material science, leading to the development of new materials that are lighter, stronger, and more sustainable.
So we could have solar panels that are more efficient, batteries that last longer, and buildings that are both.
Those are just a few examples. The possibilities are truly endless. Quantum computers could help us create a world where technology is not just about convenience, but about sustainability and solving global challenges.
It's inspiring to think about the positive impact this technology could have. But I also have to ask, are there any potential downsides?
That's a crucial question. Like any powerful technology, quantum computing has the potential for both good and bad. One concern that's often raised is the impact on cybersecurity.
Okay, I can see how that would be an issue. We rely on encryption to protect everything from our online banking to our personal data. Could quantum computers crack those codes?
That's the fear. Some encryption methods that are considered secure today could be vulnerable to attacks from powerful quantum computers in the future.
So are we all going to be walking around with tinfoil hats, trying to protect our data from quantum hackers?
No need for tinfoil hats just yet. The good news is that researchers are already working on new encryption methods that are resistant to quantum attacks. It's a bit of a race against time, but it's a challenge that the cybersecurity community is taking very seriously.
That's reassuring to hear. So it's a potential threat, but one that we're actively working to mitigate. Are there any other concerns we should be thinking about?
Another area that often comes up is the potential for job displacement. As quantum computers become more sophisticated, they could automate tasks that are currently performed by humans.
So some jobs might become obsolete.
It's a possibility, but it's important to remember that throughout history, technological advancements have always led to new industries and new job opportunities. The key is to adapt and prepare for the changing landscape.
So it's not necessarily about losing jobs, but about changing jobs. We might need to learn new skills and embrace new opportunities.
Exactly. And there's another potential downside that's worth considering. What happens when this incredibly powerful technology ends up in the wrong hands?
You're talking about the potential for misuse. Quantum computers could be used to develop new weapons or to manipulate information in ways that could be harmful.
That's right. It's crucial that we have ethical guidelines and regulations in place to ensure that quantum computing is used responsibly and for the benefit of humanity as a whole.
So it's not just about building the technology. It's about building the safeguards and the ethical framework around it.
Absolutely. We need to think about the potential consequences of this technology and ensure that it's used in a way that aligns with our values and our vision for a better future.
We've covered a lot of ground here, from the potential benefits of quantum computing to the potential risks. It's clear that this technology is going to have a profound impact on our world. But I think we need to take another pause here and let all of this sink in before we move on to the final part of our quantum deep dive. Welcome back, ready to finish our quantum journey.
Let's do it.
We've talked about how this technology could revolutionize medicine, reshape industries, and even help us tackle climate change. But I have a feeling we've only scratched the surface.
Yeah, you're absolutely right. There are some truly mind-boggling possibilities out there. What if we could use quantum computers to unlock the secrets of the universe itself?
Okay, now you're really getting into science fiction territory. What do you mean by unlocking the secrets of the universe?
Imagine being able to simulate the Big Bang, understand the nature of dark matter, or even explore the possibility of parallel universes. These are questions that have baffled physicists for centuries, but with quantum computers, we might finally have the tools to find answers.
That's incredible. So we're not just talking about making our lives a little easier or solving practical problems. We're talking about potentially rewriting our understanding of the universe and our place in it.
Exactly. Quantum computers operate on the same principles that govern the universe at its most fundamental level. By harnessing that power, we could unlock insights that are currently beyond our grasp. Who knows what kind of scientific breakthroughs await us?
This is all incredibly exciting. But I also feel a sense of responsibility here. This technology is so powerful, we need to make sure it's used for good.
Yeah, you're hitting on a critical point. The ethical implications of quantum computing are immense. We need to ask ourselves tough questions about who controls this technology, how it's used, and what safeguards are in place to prevent its misuse.
So it's not just about the science, it's about the ethics. We need to make sure that quantum computing benefits all of humanity, not just a select few.
Absolutely. We need to have a global conversation about the ethical implications of this technology, involving not just scientists and engineers, but also policymakers, ethicists, and the public.
So what can we as individuals do to make sure this technology is used responsibly? Should we all be reading up on quantum physics?
Well, understanding the basics of quantum computing certainly helps, but it's not just about technical knowledge. It's about staying informed, engaging in discussions about the ethical implications, and demanding transparency from the companies and governments developing this technology.
So we need to be informed citizens, actively participating in shaping the future of this technology.
Exactly. The future of quantum computing is not predetermined. It's something we're actively shaping with each decision we make.
Okay, I'm feeling a little overwhelmed, but in a good way. It's clear that this is a topic we need to keep learning about and discussing.
I agree. And remember, even though quantum computing might seem like something out of science fiction, it's already starting to have a real-world impact.
That's right. We talked about some examples earlier, like how it's being used in materials, science, and finance. Are there any other areas where it's making a difference?
There are so many possibilities. For example, Quantum computers could revolutionize logistics and supply chain management. Imagine being able to optimize delivery routes with a level of precision that takes into account traffic patterns, weather conditions, and even fuel efficiency. This could have a huge impact on everything from the cost of goods to our carbon footprint.
So quantum computing could make our world more efficient and more sustainable at the same time.
Exactly. And let's not forget the potential impact on artificial intelligence. Quantum machine learning is still in its infancy, but some experts believe it could lead to AI systems with capabilities that dwarf anything we've seen before.
It's both exciting and a little unnerving to think about the potential of this technology.
It is. But I believe that if we approach quantum computing with a sense of responsibility and a commitment to ethical development, it has the potential to unlock a future that is both prosperous and sustainable for all of humanity.
Well, that's a great note to end on. It's been an amazing journey exploring the world of quantum computing with you. I feel like we've only just begun to uncover the possibilities, but I'm leaving this conversation feeling both informed and inspired.
Me too. It's clear that quantum computing is a force to be reckoned with, but ultimately its impact on the world will depend on the choices we make today.
So as we step into this quantum future, let's remember to ask ourselves not just what can quantum computing do, but what do we want quantum computing to do?
That's a great question to carry with us. Thanks for joining us on this deep dive.